Hi there, my name's Miss Selby and today I'm hopefully going to teach you a little bit about momentum and importantly how to apply this in your exam. So I'll show you a few examples, show you how to work things out. So the first stop of the day, rugby pitch. But before we get started, let's just take a look at what momentum actually means. Now, anything that is moving is going to have some momentum. And momentum tells us how difficult it is to stop that moving object. And this relies on two things. The first thing is the mass of the object, and the second thing is the velocity of the object, or how quickly it's going. And to calculate an object's momentum, we multiply the mass of the object in kilograms by the velocity of the object in meters per second. Okay, so let's investigate that equation a little bit further and use our rugby ball as an example. Now if I throw this with a low velocity, so a low speed, its momentum is going to be fairly low, which means this is going to be easy to stop. If I throw this with a high velocity, so a high speed, its momentum is going to be higher and therefore it's going to be more difficult to stop. Likewise, if I take something which has a low mass, like a ball pool ball, and I throw this, that's going to be fairly easy to stop because it's got a low momentum. If I, however, take something with a large mass, like a shot put, and I throw that, because we've got a higher mass, we have a higher momentum, and that means it's more difficult to stop. Okay, so in this film, I want to take a look at two examples of momentum at work. The first one is about stuff crashing into each other, which from now on we'll refer to as a collision. And the second is about something called recoil, which I'll explain a little bit later on. So let's go and find a collision. I've borrowed some brave volunteers from our school rugby team to show you what I mean. So before we start having a look at the maths involved in calculating momentum, there's one rule that's really going to help us out. And that is the total momentum before an event, so that could be a collision, it could be firing a gun or kicking a ball, must be the same after that event. And we know that as the conservation of momentum. So the first thing we need to do is look at the information we've been given. Now if we calculate the momentum of our player on the left, he's got a mass of 65 kilograms, a velocity of 7 meters per second, so he has a momentum of 455 kilogram meters per second. Our player on the right has a mass of 70 kilograms but no velocity and therefore no momentum. And if we add these two together, we end up with a momentum of 455 kilogram meters per second. Now because we know the momentum has to be conserved, we can now calculate the velocity that these players hit the floor with. So we know the momentum is 455 kilogram meters per second. They are now joined together, so we add their masses together, which gives us 135 kilograms. And then it's just a case of substituting into our formula, doing a little bit of maths, and we end up with a velocity of 3.4 meters per second. So what about, instead of considering things moving towards each other, we now consider things moving away from each other? So if we look at the example of firing a gun, we're going to have the bullet going in one direction and the gun recoiling in the opposite direction. And this means they're going to have opposite momentums. But it still has to obey our conservation of momentum rule. Now, one of the examiner's favourite topics is to ask whether or not you can calculate the recoil velocity of the gun. So that's what we're going to have a look at. So let's watch our volunteer as he fires the gun, and notice the direction the gun travels in once the bullet's fired. That backward motion is called recoil. So before we shoot the gun, we need to consider both the mass of the gun and the mass of the bullet. So if we estimate that the mass of the gun is about 3.5 kilograms and the mass of your average bullet is about 20 grams, then the total mass is 3.52 kilograms. But because we've not shot yet, there's no velocity anywhere, and therefore the total momentum has to be 0. So the total momentum before we shoot is 0. But we know that we need to conserve momentum, so how is it possible that we've still got 0 momentum even after we fire the gun? Well, because our gun and our bullet are moving in opposite directions, they're going to have opposite momentums, and we need to make sure that they cancel out. So let's say our bullet has a mass of 0.02 kilograms and is fired at a velocity of 1,600 meters per second. The momentum is 32 kilogram meters per second. Now, because the momentum after the shot has to be 0 because of our conservation of momentum rule, we now need the gun to have a momentum of minus 32 kilogram meters per second to cancel out the momentum of the bullet. So all we need to do now to calculate our recoil velocity
is to substitute in our momentum of minus 32 kilogram meters per second along with our mass of 3.5 kilograms, and to slot those into our equation, and we end up with a recoil velocity of minus 9.1 meters per second, and it's negative because it's in the opposite direction to the bullet.
Okay, so we've got one last thing left to look at, and this part explains how momentum and how it changes can actually save your life. Okay, so one of the examples that examiners are really keen on is to ask you to explain how an airbag works in terms of momentum. So I'm going to show you a little demonstration. I'm going to use this guy to represent our driver or our passenger, and I'm going to use just a normal plastic bag filled with air to represent our airbag. So to start with, let's imagine that the surface of the table represents the dashboard of a car, and have a look at what happens to our driver without the airbag. Okay, so even from the sound of that, you can tell that there's a big force there, and that's what's going to hurt you in a car crash. Now, if we replace the dashboard with an airbag, let's have a look what difference that makes. Okay, you can tell there's not as big a force, and therefore it's not going to hurt as much. Now, we can actually represent this information as an equation. Now, the equation you get given in the exam, so you don't need to worry about memorising it, but it's really useful to learn how to apply it. Now, the equation is the force equals the change in momentum divided by the time it takes to change that momentum.
Hopefully you've had some experience of the high jump when you've been doing PE at school. Now, the crash mat that you land on works in exactly the same way as our airbag from before. So let's calculate the force that's exerted on your body when you do the high jump. So let's calculate his momentum before he hits the crash mat. He has a mass of 60 kilograms, a velocity of 4 meters per second, and therefore he has a momentum of 240 kilogram meters per second. Now when he's landed, so when he's stopped falling, he's now got no velocity, and therefore he's got no momentum. So to begin calculating the force, we first need to calculate the change in momentum. So before he landed, he had a momentum of 240 kilogram meters per second, and after he landed, he had a momentum of 0. So the difference between the two is 240 kilogram meters per second. So if we estimate that our jumper is in contact with the crash mat for 2 seconds, our final step is to substitute those values into our equation, which gives us an overall force of 120 newtons. So hopefully this has given you a better idea of what momentum is and how to apply that knowledge in your exam. Best of luck!